Hello everyone, welcome to VisionGATE. And yesterday we have completed phase modulation and frequency modulation. So let's have a little introduction of yesterday class, then we will solve some important previous year GATE question. तो लास्ट क्लास में हम लोगों ने क्या पढ़ा था? मैक्सिमम फ्रीक्वेंसी डेविएशन एंड मैक्सिमम फेज डेविएशन ऑफ PM and FM signal. So how to find? So let's take a formula, then we will solve the questions. So delta phi, this is the maximum phase deviation that is given by maximum of phi t. Okay, and delta f, this is maximum frequency deviation. This is given by maximum of 1 by 2 pi differentiation of phi t with respect to dt. Okay, so see, and it is under the mod. If it is come negative value अगर आता है तो उसको mod लेंगे तो हमेशा पॉजिटिव आएगा डेल्टा फाई एंड डेल्टा एफ का वैल्यू. So see here, this is a universal formula. If there is any message signal, you can use this formula. But let's suppose our message signal is sinusoidal signal. Mt is given, that is sinusoidal signal, that is equal to am cos 2 pi fmt. Okay, so in this case our delta phi in PM signal, yesterday we have already found, that is kpam. Okay, and delta f of PM signal, that will be is equal to kpam fm. We have already found using this formula only in yesterday class. Now for frequency modulation, delta phi when the message signal is sinusoidal, this is very important. You can use this formula only if the message signal is given as sinusoidal signal. अगर message signal rectangular होगा, triangular होगा, तो हम लोग ये वाला formula apply करेंगे, that is universal formula. So now delta phi for FM, that is given as kf am by fm. Okay, we have already found yesterday. And delta f, that is maximum frequency deviation of FM signal, that is equal to kf am. Okay, so up to this we have already derived and found. So today we will do some of the important previous year GATE question. So let's take a important GATE question. This is a previous year question of GATE. Question is, following message signal. See, I am giving you only few GATE question, but you should attempt all the GATE question of electronics, electrical and instrumentation branch, because if you will attempt various question from different branch, then you will gain the ability to solve new problems if it comes in the GATE examination. Okay, so solve as much number of problem, and after solving all this you can solve the different coaching materials, but that is not required if you are solving 3 branch previous year GATE question. Okay, so let me write the question, then I will explain it, and I will give you 2 minutes to solve this question. See, the question is, FM signal are same. The question is, the message signal is given, that is, here is our message signal graph I am giving you. This time message signal is our rectangular signal, like in this fashion. Okay, so this amplitude is given to, this is -2. So this is our message signal given to both the frequency and phase modulator. In both FM and PM, this message signal is given. You have to find the ratio Kp by Kf such that maximum phase deviation of resultant of PM and FM signal are same. Maximum phase deviation are same, and you have to find Kp by Kf. So I'm giving you 1 minute to solve this question. This is a previous year GATE question. I will give you options also. Okay, let's take a 2 minute. So solve this question and reply the answer in the comment box. Okay. So option A is 2, option B is 2 pi, option C is 4, and option D is 4 pi. And such kind of question came in GATE 2020 also. You can go and check the GATE 2020 question which came to solve this question. See, this time the message signal is rectangular, so we cannot use the formula blindly. We have to use our universal formula. Okay, so just comment your answer and solve all the question from electronics, electrical and instrumentation branch. This will give you more practice and better way. Okay, because we are solving a very less amount of question due to time constraints, and those questions are important and giving you some concept. So okay, 50 seconds left. Comment your answer in the comment box. 40 seconds left. This is a very important question because last year also came GATE repeated. See, GATE examination repeat the concepts of question in every year. They do not ask, they ask only few new question. Like in 2020 there was 5 to 7 new question based on the new concepts, but all other remaining questions are same, so you can easily get 70 plus marks if you solve all the questions. So your time is up. Now I'm going to solve this question. So see, what is given, the maximum phase deviation of resultant of PM and FM signal are same. Read the question twice. That is very important in the examination. So delta phi, that is maximum phase deviation of PM and FM signal are same. So delta phi of FM. And one important thing, note point. We have already find delta phi of PM is kpam, that is equal to delta phi of FM was kf am by FM. But the important point is this, that we cannot use this formula here. Why? See, many times students commit this mistake. That's why I am writing this point. We cannot use this formula here. Formula as message signal is not a sinusoidal signal. ओके, हमारा मैसेज सिग्नल जो है साइनोसॉइडल सिग्नल नहीं है, इसीलिए हम लोग ये फॉर्मूला यूज नहीं करेंगे. सो दिस फॉर्मूला कैन नॉट बी एप्लीकेबल हियर. तो अब यहाँ पे क्या अप्लाई करेंगे, मैक्सिमम ऑफ फाई टी. डेल्टा फाई इज इक्वल टू मैक्सिमम ऑफ फाई टी under mod. This formula is applicable. This is the universal formula. So what is the phi t of phase modulator? That is, phi t is kp into mt. Okay, we have already seen in the general expression of PM signal. And what is the phi t of FM signal? That is 2 pi kf integration of mt dt. Okay, this we have already seen in the general expression of Pm and Fm. So see here, if you will integrate this, because we need the integration here, then you will get, I will draw, if you are going to integrate this, the integration will come like this, because see, it is a constant. So if it is 2 dt, and if you will integrate, it will come 2t. Okay, so understood, 2t. So it will be having a slope like this. So the integration will come like this. So if the slope is 2t, slope is 2. So if this point is 2 here, sorry I missed this point. So if this point is 2, 4 and 6 here, so the slope is 2. So our this point will be 4, 2 into 2, 4, and this will be also 4. So this is the integration. So now the maximum of kpmt here, that will be equal to kp, and maximum of mt is 2 here. Message signal is in the red curve. So kp into 2, that is equal to 2 pi kf, and maximum of integration is 4. Now when you will do kp by kf, you will get 2 pi into 4 divided by 2. So you will finally get the answer 4 pi. This was a very interesting question you have seen. So option D is the correct. The students who gave option D, that is the correct option. Okay. So let's solve one more question. Let me find the question. Okay, before solving it, just a small concept, let's study. Multi-tone modulation. Like earlier we studied single tone modulation. In single tone, what happened? Only one frequency component is present. In multi-tone modulation, message signal में multi-frequency component is present. So the modulation index in multi-tone modulation will be, modulation index is deviation ratio, that is beta, that is equal to delta f by fm. Okay, and this is valid for only this is valid for all the message signal, because this is universal formula again. Even if it is sinusoidal, rectangular, it is valid for all the message signal. So beta of fm, that is equal to delta f of fm divided by f max. What is f max? Let's suppose in multi-tone modulation, fm1, fm2 or up to fmn is present. So our f max is equal to maximum from fm1 comma fm2 dot fmn. Okay, so it is in the maximum from all this value, maximum of all the frequency component present. Simple. See, we have already studied delta f by fm is beta, but here instead of fm we will use f max. F max is maximum of all the frequency component present in the multi-tone modulation. Now beta of phase modulation, that is equal to again delta f of pm divided by f max here. If it is single tone, then we will use fm, because single frequency component is present. But if it is multi-tone modulation, तो f max लेंगे. F max मतलब maximum of all the frequency component present. Now bandwidth using the Carson's rule, bandwidth of FM or either PM, both using the Carson's rule, is given as beta. If it is asked for FM, then FM. If it is asked for PM, then PM. Beta plus 1 into 2. Earlier we have used FM, but here it is multi-tone modulation. यहाँ पे हम लोग F max लेंगे. So after substituting beta, delta F by F max, this F max and F max get cancelled, and the final formula for the bandwidth is delta F FM or PM plus F max. Okay, so up to this clear, and the total power is given as AC square by 2R. So done in FM or PM signal. So this was just a small concept. Let's solve one question. This is again previous year GATE question. Question is ST is given, that is 10 cos omega CT plus 5 sin 2 pi FM T. Okay. And in this question, FM is also given, the message of frequency of the message signal, that is given as 1 kilohertz. Okay, so now you have to find the bandwidth. This is a very simple logical question. Find bandwidth of phase modulator signal. Okay, so if it is given phase modulator signal, then this is our Kp into Mt. So now, so beta is Kpam, that is given here 5. Okay, and this beta is for phase modulator. So now our bandwidth will be beta plus 1 into 2FM. So beta is 5, so that will be 6 into 2 into 1, that is equal to 12 kilohertz. Okay, now one more extension we are doing. Let's suppose amplitude is increased by 2 times and frequency is decreased by 2 times, so that is equal to half kilohertz. So what will be our beta? Beta will be 5 into 2 because amplitude is increased. So Kpam is 10. Beta became 10. So now the bandwidth will be beta plus 1 2FM. Beta is 10 here. So 10 plus 1 into 2FM. FM is getting half. So 2 into half. That is equal to 11 kilohertz. So see, if amplitude is increased and frequency is decreased, there is no such relation that it will become double or half of. We have to find the bandwidth using the formula. So let's take, I will directly write here 12 because this side I want to solve one more part of this question. Let's suppose this is FM signal. When FM signal, so if FM signal is there, then this part it will be 2 pi kf and integration, but no need to write this directly. We will write beta is equal to 5, and beta in the FM signal, if it is sinusoidal message signal, that is kfam by fm. So bandwidth will be 2 into delta f plus fm, and delta f is kfam because beta is also equal to delta f by fm. So delta f will be beta into fm, so that is equal to 5 into fm is 1 kilohertz, so that is equal to 5 kilohertz. So it will be 2 into delta f is 5, fm is 1. So again that is 12 kilohertz. Okay. Now see delta f is our 5 kilohertz. Okay, fine. And fm is okay. So now if am is means magnitude is increased by 2 and frequency is decreased by 2, so new bandwidth will be in this case 2 into delta f plus fm. So see, fm is decreased by 2 and delta f is same here, because delta f does not depends on fm. We have already studied this. So delta f will be same again, just because see why, see beta, if if am is means magnitude is increased by 2, so beta will be 5 into 2 and delta f will be beta into fm. So that is equal to 10 into, and fm is reduced by half, so that will be equal to 5. So delta f is always 5 and fm will be half. So again that will be 11 kilohertz. So okay, understood this concept? So now let's take a last question from this topic. This question is very important. Give a smart star mark here. This might come in the next year GATE examination. This question is taken from the standard book. Our message signal, our signal st is given as cos omega ct plus 0.5 cos omega m t sine omega ct. Okay, and they are asking you this signal is AM signal. 4 options are given. AM signal only. Option B, only FM signal. Option C, both. Option D, neither AM or FM. So I will give you 1 minute to solve this question. See, the question is given, the signal is given, ST is given, and you have to say using by looking at the equation, solve this equation, that whether this signal is either AM or FM or both or neither of the AM or FM. So we have 45 seconds. Just comment your answer below. What will be the answer for this question? So only 15 seconds left. Just solve it fast. So the time is going to over. Now I will solve this question. See, for solving this question, first we should know that this signal is in this form of A cos omega ct plus B sin omega ct. This is our B and A is here 1. Okay, so if it is given in this, so using the trigonometry identity, this can be simplified as A square plus B square, the magnitude, into cos omega ct minus phi, and phi is here, that is equal to tan inverse B by A. So we will use this formula. So our ST will be under root A square plus B square. So A square is 1 plus B square, that is 0.5 cos omega mt square. Okay, and cos omega ct minus phi. Phi is tan inverse B by A. So tan inverse B is 0.5 cos omega mt divided by 1. So I will write it again. So this will be 1 plus 0.25 cos squared omega mt cos omega ct minus tan inverse 0.5 cos omega mt. Okay, so this is our equation for the st. So now you see, for AM signal magnitude should vary. So when omega m will vary, this will also vary. And if omega m will vary, here this theta t will vary. So this is angle modulation also and amplitude modulation also. But in angle modulation only FM is there. If it is, it might be PM also. So here this is AM signal because this is varying and this is varying. So this is FM signal. So AM and FM both will be the answer. So option C is the correct option. So whoever gave option C, that is absolutely correct. Okay. So now the next topic is, this is totally theoretical topic. This topic is useful in examination like bar or ISRO. Demodulation of FM, and one question came in GATE from here also. That example I will take at the end. So first let me take the demodulation of FM. So there is two techniques. First, I will teach this topic little faster because this kind of theoretical topic is not that much useful in the GATE examination. So the demodulation of FM is done using frequency discrimination method. In this, the first method is slope detector. Just this is theoretical topic, no need to study slope detector. What is balanced slope detector? And one more method is phase discrimination method. In phase discrimination method, there are three more types like Foster, Sele detection, ratio detection, and option C, PLL detector. So we have to study only this C part for GATE examination. Why? There is one reason. Let's have a note point. The note point is, except PLL. PLL is phase lock loop. Other FM demodulators needs transformer. सी PLL के अलावा दूसरा जितना भी डिमोडुलेटर है उसको ट्रांसफार्मर चाहिए. एंड ट्रांसफार्मर, यूज ऑफ ट्रांसफार्मर इज for their construction. Use of transformer is very disadvantageous because see, if you are using transformer, then transformer is bulky and costly. So we will use PLL because this does not require transformer. So for FM demodulator, PLL is preferred. Why PLL is preferred? Because see, for all other demodulation technique, transformer is required and transformer is bulky, and so we do not use this. So now we will directly study PLL detector, and after studying PLL detector, we will solve one question. Okay, and after solving that question, our PM and FM is over. So very small topic, only it will take 5 minutes and one question we will solve. Okay. So PLL detector, the block diagram of PLL detector is, we are having here multiplier, low pass filter, and one feedback is given. This is voltage control oscillator. I will tell you what it is. And here FM signal is given. And this multiplier we can replace it also by phase detector. That is PLL detector of FM signal. So you can use multiplier or you can replace it using phase detector. So in the process of maintaining frequency synchronization, see here the message means the signal as FMT and the message signal coming through voltage control oscillator, we need to maintain the frequency, means synchronization of frequency, means both their frequency will be same. So local oscillator is replaced by voltage control oscillator. Here we are using voltage control oscillator instead of local oscillator because we need to synchronize the frequency of message signal and FM signal. So frequency at this voltage control oscillator output varies according to the message signal amplitude. So amplitude के हिसाब से voltage control oscillator जो है frequency को मतलब vary करता है और it synchronize, and that synchronized frequency will maintain with respect to the FM signal to be demodulated. So no need to write this point, I have already explained. I will tell you again. Here we are using VCO, voltage control oscillator, instead of local oscillator, just because voltage control oscillator change frequency with respect to the amplitude of the message signal. तो यहाँ पे हमें फ्रीक्वेंसी को सिंक्रोनाइज करना होता है एफएम सिग्नल का और मैसेज सिग्नल का, तो सेम फ्रीक्वेंसी लाने के लिए वोल्टेज कंट्रोल ऑसिलेटर यूज करते हैं. सो नो नीड टू राइट दिस पॉइंट, आई हैव एक्सप्लेन्ड यू. जस्ट राइट अनदर पॉइंट. Provided frequency synchronization is maintained, means let's suppose the frequency synchronization is maintained at the multiplier, then PLL, that is phase lock loop, set to be in locked mode. अगर frequency synchronized है, then this PLL is set to be in locked mode. Okay, sometimes they may ask that the PLL is in locked mode. So in that case, the message signal and FM signal will have the same frequency, synchronized frequency, provided if phase synchronization is maintained, means the message signal and FM signal have same phase. Phase synchronization is maintained, then PLL is set to be in capture mode. So this is just two term. This might come in bar examination, such type of EG examination. So what is locked mode? When frequency synchronization is maintained at multiplier, then PLL is set to be in lock mode. When phase synchronization is maintained, then PLL is set to be in capture mode. So one formula also write. PLL detector output. See, this multiplier is only the PLL detector. So at this place, output, that is equal to Kf by Kv into Mt. Okay. And what is Kf? Kv? Kv is the frequency sensitivity of VCO, means voltage control oscillator, and unit of Kv, I will write, Kv is frequency sensitivity of VCO, that is voltage control oscillator, and its unit is hertz per volt, and kV is frequency sensitivity of FM signal. Okay, so now let's take an example. This is previous year GATE question. The question is, the block diagram is given. Very simple question. Such question came in ESC exams also. Okay. Low pass filter is given. See, this block diagram is the matching with PLL detector. Here phase detector can be used instead of multiplier. I have already told you. And here it is message signal, and in feedback message signal is passed through voltage control oscillator, which synchronize the phase, and it is passed through a frequency divider. This is frequency divider. Okay, so there are three keys for the frequency divider. Divide by 2, second key is divide by 4, third key is divide by 6, and this signal is passed to phase detector, that is multiplier also, and the frequency of FM signal is 5 kilohertz. So question is, here this is F dash. Okay, question is, find F dash to be synthesized if switch is replaced by switch is repeatedly connected to the positions of 1, 2 and 3 respectively. Okay, so what is this question? You have to find F dash to be synthesized if switch is repeatedly connected to the position 1, 2, 3. In first position the frequency divided by 2, and in second position frequency divided by 4, and in third position frequency divided by 6. And one more thing, when nothing is given, that whether PLL is in locked mode or capture mode, then default is, when nothing is given, then default is PLL is always in lock mode. Lock mode means frequency should be synthesized. So see, our FM signal 5 kilohertz is given. You have to find for all those three part. I am giving you 1 minute. Comment your answer below. See, you have to just frequency multiplier technique you have to apply. Very simple question. Every time the message signal means this FM here, means here some frequency will come. F this and this 5 kilohertz should be same. I have just given you the hint. Just solve this question for all the three position. If switch is repeatedly connected to all the three position, you have only half minute. Just give the answer in the comment box fast. So see, today our this part is over, and after that we will start sampling, and after sampling theorem we will start our digital communication. And see, little remaining part of analog communication we will study at the end of the communication system, because from there questions are not coming in the GATE examination regularly. So no need to waste time at the starting. At the starting our Josh is high always, as we text in WhatsApp group. So we should study the important topics. See, default PLL is in lock mode, so frequency is synchronized. So for the position 1, frequency into half, that should be is equal to 5 kilohertz. So our F dash is equal to 10 kilohertz. Okay. At the second position, F dash, it is means this frequency dividing the frequency by 4. So F dash into 1 by 4 is equal to 5 kilohertz. So our F dash is equal to 20 kilohertz. In the third, F dash, it is dividing by 6. So 1 by 6, that is equal to 5 kilohertz. So our F dash is equal to 30 kilohertz. So today we are going to finish here only. In the next lecture we will start with sampling theorem. See, before starting digital communication we should know how to convert analog to digital signal, and after that we will start digital communication. In that we will study first ASK, PSK and FSK. What is ASK, PSK, FSK? Amplitude shift keying, phase shift keying and frequency shift keying. So sampling theorem is basics for the digital communication, because using sampling theorem only we can convert analog signal to digital signal. All the natural signal present is analog. First we have to convert in the digital signal. And what is the required of digital communication? It makes the speed of transmission faster. That's why we are using digital communication. So okay, thank you all for watching this lecture, and keep on practicing problem from various branches like questions of electronics, electrical and instrumentation branch for GATE examination, and you can apply for 2 branch also this time, so it will be very helpful. Thank you all. Bye bye.